Let's begin by working out the bounds of some numbers. So we want to find the upper and lower bound of 3.6 metres where it's been measured to the nearest 0.1 metre. I like to do this using a scale. 3.6 metres in the middle. Our next value on that scale would be 3.7 and the previous would be 3.5. To find our bounds, we're looking at the values between these two, 3.55 and 3.65. What we should notice is that there is going to be a difference of 0.1 between these two values. This is our lower bound and this is our upper bound. Next, let's look at 250 metres rounded to the nearest 50 metres. So again, we'll use our scale method, 250 metres in the middle. Our next reading would be 300 metres, our previous 200 metres. To find our bounds, we go between, so that's 225 and 275. Again, we notice that our bounds have a difference of 50 metres, our lower bound and our upper bound. If we were to look at the bounds of 43, which is rounded to the nearest two significant figures. Again, we use our scale. The next number to two significant figures is 44, the previous is 42. We go between these two, 42.5 and 43.5 for our lower bound and our upper bound. Now using bounds in context of questions. What we have here is a right angle triangle where we want to find out the length of a missing side. A right angle triangle, length of a missing side, we're going to be using Pythagoras. Now it's not just a straightforward Pythagoras question. Now remember, a squared b squared equals c squared, where c is always the hypotenuse. We want to find the upper bound of x. So a squared plus b squared equals c squared. In this case, our b is our x squared. So we're finding b, which is c squared minus a squared. Now I want you to consider you're finding the greatest possible value for this b. To find the greatest possible value, you need to find the greatest value for c and subtract the lowest possible value for a. So we're combining different bounds. So use our scale, 10.4, 10.5, 10.3, lower bound, upper bound. Our upper bound is 10.45. So b squared equals 10.45 squared minus, we want the lower bound of a. Use our scale. Lower bound, upper bound, that's 3.55 is our lower bound of a. Now we use our calculator, substitute in. 10.45 squared minus 3.55 squared. That gives us 96.6. Now we want to find the square root of that. 9.828529. Our question hasn't said round your final answer because we don't know that the lower bound isn't something very similar but with only a few decimal places at the end different. So typically with bounds we want to leave the decimal places unless we get a question that says to give your answer to a certain number of significant figures or to a certain degree of accuracy. So I'm just going to add that onto this part of here. So we want to calculate the upper and lower bound for Dan's value of pi. And then we're going to give our answer to a suitable degree of accuracy. Now this would be a 5-mark question with this extra little bit at the end, and we would typically see this at the very back of a higher paper. Now, he measures the circumference and the diameter of a circle. He measures the circumference as 170 millimetres to the nearest millimetre. So the next millimetre, or the next reading on our scale, is 171. The previous is 169. So 169.5 and 170.5. There is a difference of 1 millimetre between them. Same thing, we'll look at our bounds for the diameter, 54 millimetres to correct the nearest millimetre. So we find our bounds by going between. So 53.5 and 54.5. Now next we've been given the formula to calculate pi. Pi is the circumference divided by the diameter. Now what I want you to think of here, if we're finding the upper bound of pi and the lower bound of pi. So we want the greatest possible value for this. So think about a cake. If you have a cake, do you want a large cake and share it with a few people to get the biggest slice possible? Or do you want a small cake and shared between a large amount of people? To get the biggest slice cake possible, you want to use a large cake and you want to share it with the least amount of people possible. So in context of this question, we are going to be doing, if you're trying to find the upper bound and we have a division, you're going to be doing the upper bound numerator divided by a denominator of the lower bound. And that will be vice versa if we were finding the lower bound. That's lower divided by upper. So now we substitute in our values. So the upper bound of the circumference was 170.5 divided by 53.4. Then we've got 169.5 as the lower bound of the circumference divided by 54.5. Pop these into your calculator. 170.5 divided by 53.5, and we get an answer of 3.186915888. No need to round just yet. Now the lower bound, 169.5 divided by 54.5. 3.110091743. That would be our final answer if we were just answering this question, but we've got this little extra here. We want to give to a suitable degree of accuracy. What this means is you are trying to round both answers to the greatest number of significant figures where both answers round to the same thing. For example, if I rounded to 3 significant figures in both cases, the first one I would get 3.19, the second 3.11. That's not the case. If I rounded to 2 significant figures, I would get 3.2 for the first, and then I would get 3.1 for the second. They're still different. So actually for this question, I can only round to one significant figure, which is 3. Let's try one more bounds question. Steve travelled from Ashton to Barnfield. He travelled 235 miles. Correct the nearest 5 miles. So our scale, we're going difference of 5 miles. That's 232.5 miles and 237.5 miles as our lower bound and our upper bound for the distance. The journey took him 200 minutes. Correct the nearest 5 minutes. 205 minutes, 195 minutes. 197.5, 202.5, for your lower bound and your upper bound of the time. Calculate the lower bound of the speed. Now remember, speed equals distance over time. If I want the lowest bound possible, I want the smallest cake divided by the greatest number of people. I want my answer in miles per hour. So my miles, my distance is in miles, that's fine. So the lower bound of the distance, 232.5. I want the upper bound of my time, but in hours. I need to convert this into hours. 1 hour equals 60 minutes. So to convert minutes to hours, we divide by 60. So that's 202.5 divided by 60 to get 3.375 hours. Pop that in your calculator. And that gives us an answer of 68.8 recurring miles per hour, which seems about right if he is driving a car to 3 significant figures for our final mark. So that 8 is recurring, so that is 68.9 miles per hour, correct to 3 significant figures.